Hello guys, let's see the problem. The problem name is target sum, and it's a medium level problem. So let's go through the problem statement. In problem statement, it's basically given that you have given an integer array norms and an integer target, and you want to build an expression out of norms by adding one of the symbols positive or negative before each integer in the norms, then concatenate all the integers, right? Then process all the integers. That's it. It's saying. Okay, so let's see an example, then it will be better to understand the problem statement, right? Okay, let's see. This is the norms are given. Okay, and this is the target given, target equal to 3, and obviously it's telling that there are 5 ways to assign the symbols to make the sum of the sum to the target, that is 3. So let's see what are the ways. Okay, it's actually the number of ways to arrange the integers, adding positive or negative sign in front of it. That's it. It's telling. Let's see. This is added negative sign, and this positive sign, positive, positive, positive. So this will cancel, and this all will like 3. Right. So basically, if I have my array, basically I have my array 1 1 1 1 1. It's the array it's given. So basically it's telling that I have to divide the array into two parts. Suppose this is the part s1 and this is the part s2. Okay, I have to divide it into two subsets, I can say, right? This is one subset and this is another subset, such that the difference between those subsets will be equal to target. It's actually the same thing, right? It's actually the same thing. Just try to look at closely, right? The negative side depicts just the same thing as second subject. So we can write s1 minus s2 equal to target, isn't it? This is the first thing we can observe from these examples, like from going through all the examples, right? S1 is the sum of subset 1, s2 is the sum of subset 2. Okay, this is the thing. Let's say this is our equation 1, and we know, suppose there is a set, I can say this is an array, and suppose I am dividing into two subsets. So the sum of both subsets will be the sum of all the elements of the array, isn't it? So what I can say over the sum of the both subsets that I have divided, I can say it's s1 plus s2 equal to sum of the array, or I can say the sum of the norms. So from these two equations, can I find the sum of s1? That is, can I find s1? Obviously I can find it as the two equations. If I'm adding the two equations, I'll be getting 2s1 equal to target plus sum of the array. So directly I can write s1 equal to target plus sum of the array divided by 2, right? This I can directly write, isn't it? So now you just see what has asked in that problem and what we have to calculate now. We completely converted this problem, into another different problem, in which the first thing is you have to divide the given set or given array into two subsets. Okay, and the difference between two subsets is equal to target. That is the first observation. And the second observation is your both subsets sum is equal to the sum of the entire array. That is your second observation. And from these two observations, we found that the sum of the first subset will be equal to this, isn't it? Will be equal to this. So what we can say now out of this problem? If I'll write the converted problem, I can write like this. We'll have a sum given, because these we can find obviously, this is obviously given, target is given, these we can calculate by just looping through the array. So we can kind of say this is given, the sum of one subset is given, right? So can I convert this problem to another problem saying that the number of ways to find a subset of a given array having sum equal to s1. Can I convert this problem like this? Just tell me. Obviously I can convert, because as per our first observation and second observation, we can convert this problem to exactly this problem, and this is something a different kind of problem, right? This is something a different kind of problem. Okay, then this is our first checkpoint. Is the first checkpoint is we don't have to solve this problem now. We don't have to solve this problem now. We have to solve this problem now, right? If we can solve this problem now, then our original problem is going to be solved. That's it. Okay, so let's see how we can solve this particular problem, right? Okay, the number of ways to find a subset of a given array having sum equal to s1. Just think the approach of solving this problem, this particular problem, right? Just think some keywords, like just observe some keywords. The number of ways of finding a subset. Can I relate this problem to exactly one problem, like the standard problem of backtracking? That is is there any subset of a given sum in a particular set or particular array? Can I relate this problem to that problem? In that problem, it's like is a normal array is given. A normal array is given. You have to find a subset whose sum is of a given like given element, and you have to return true or false, right? You have to return true or false. But in this case, in our case, you have to return the count of such subsets. And this is a standard problem of your backtracking, right? Backtracking. Okay, let me explain all of this thought process through an example, right? Let me clear these things now, because I think I've explained all these things. So if I have a set 2, 3, 4, 5, 6, right, and I have something like x given, that is the sum desired, right, like desired sum of my subset. Okay, so while finding a subset in backtracking, there is a general way of solving like almost all the backtracking problems, right? We can actually divide into 4 parts: label, choice, check, move. So first, label means what are the different labels we have. Here in this problem, in this array, this is our array. In this problem, what are my labels? My labels are can I take this element, can I take this element, can I take this element. These are my labels, right? Each element in this array are my labels, right? And what are the choices? I have only 2 choices. For each element, I have only 2 choices. I can take it or don't take it, right? Don't take it, right? These are the 2 choices. That is meant by choice. I already explained what does it mean by label and what does it mean by choice. Third thing, check. Like if I take this element, what's gonna happen? And if I don't take this element, what's gonna happen? We're going to see much of it in the actual code, but this is the general approach to solve any backtracking problem. And then move means, suppose if I'm proceeding with taking that element or not taking that element. And you guys know, like there will be a recursion tree building of where like suppose from a particular thing there will be like 2 options of not taking and not taking, right? This is the taking option, this is the not taking option, and from that also there is again take or not take. So that is the move, right? So have you understood this thing? This is very important. If you understood this thing, then you can able to solve any of backtracking problems easily, right? Okay, so this is the thing. We are gonna set two variables. One variable is our take variable and another variable is our don't take variable, and we are gonna like write recursion code of it, right? Obviously you guys know that in backtracking we just write the recursion codes, right, with this template. This is the template, right? This is the template. Okay. Okay, so now I think let's see the code of this problem. In code, I'll explain more of these problems about the base cases, different base cases, and the pruning, right? And obviously, first I'll explain the recursion part, and then I'll move into the DP solution, right? DP solution, and I'll also explain the thought process of adding DP to this problem, right? DP is nothing. DP is actually the backtracking thing, right? Just adding a memorization or tabulation. Both processes are correct. It's gonna like depend what you are adding. Okay, so let's see the code. I have also added my code which I have written. Okay. Okay, so let's see from here. The array is given and the target is given, and first, as I have told, we have to calculate the sum of the array, isn't it? Sum of the array. So that's why I kept this sum variable equal to 0, and n is the norm size, that's the size of array, and just looping through all the elements of the array, I found the sum, right? Okay. For now, just ignore this part. I will explain why I added DP and what's the purpose of adding DP here. Okay. Then this is just sum 1 is just S1. S1, as I have already explained the derivation of S1. So that is equal to sum plus target by 2. Right. That's what written here. And this is one particular problem. This is one particular case. I'm gonna explain it now. Just see. If S1 equal to my sum plus target divided by 2. If my sum plus target is odd, it's itself odd, right? Then obviously I can't find a solution. Then the number of solutions will be 0, right? Suppose just imagine my this sum and target add up to 57, right? 57. So what will be my desired sum? Desired sum will be like if you divide it in C++, that will be giving the floor values. But if you do it generally in a mathematical way, what will this? It will give 57 by 2, a decimal number. So obviously if my all numbers are integers, obviously it can't add to a decimal number. It's not possible. So the number of solutions in these cases are obviously 0. You understood this? Okay. If you're not going to add this, then it will give error. Obviously, like a wrong answer error. That's it. Then another thing, these small cases are very much important, right? Then another thing is sum less than equal to target. It's actually the addition of two numbers. It's actually the subtraction of two numbers. And you guys definitely know, because the addition of two numbers will be always greater than the subtraction of two numbers. So this is kind of a pruning case, right? I would say. So I just added this case here. And now I'm calling the recursion find number of ways. This is my label, this is my label, and this is my sum. Obviously initially obviously sum equal to 0 and the label will be equal to 0 because I'm starting from this label. I'm starting from this label. This is my label. I told, right, I have to iterate through the array and see, and initially the sum will be also equal to 0. Okay, let's see. Okay, and this is the array I'm finding. Then at last I am just returning the number of ways. Okay, okay, let's see. Just for now, just ignore the TP part and let me explain the recursion part first. Okay, so this n equal to array size, this is just label, and this is sum, and this is the array. I have already explained. This is the pruning case. What is pruning? Pruning is the thing that's not going to happen. Like base case is the thing, at that stage the code will terminate, but pruning case is the thing that's not going to happen. So we are just pruning out the solutions, right? What is the pruning part? Suppose label can't be greater than n, right? So in this case I'm just returning 0, and my desired sum can't be like greater than s1 is my desired sum, so it can't be like this, right? So I'm just returning 0, return 0. Okay, and obviously the base case will be like when my label will be, I'm just iterating over this array, right? I'm just iterating over this array, and when my label will be equal to n is the size of array, then I have to check is my sum, like the current sum which I am adding, right? Is my current sum equal to s1, or here I have taken the sum 1, that doesn't matter. If this case is correct, then I would say it's a valid case and I would return 1, right? I would return 1. If this doesn't happen, then obviously it's not a valid case. I would return 0, right? Okay, just ignore this part as of now. I'll definitely explain this. This is the memorization part, and this is something important, and I have already explained this. See, this is the take case and not take case. Suppose this is the array 2 3 4 5, just for an example. And if you are taking this, right, if you are taking this, let's say if you are taking this, what's going to happen? Initially your label is here, and obviously if you are taking this element, the label will be like increasing. Label will be, new label will be label plus 1, right? Label plus 1. And what's your sum? Your sum will be sum plus ARR of label, right? That's what is written. Just see, in take equal to, I'm just calling the recursion for, like, I have solved up to this part. Now you recursion solve this part. Okay, recursion will take care of it, right? Find number of ways, label plus 1, sum plus this, and just I'm just passing the array, right? And in not take case, I'll just pass the label plus 1 because I'm in sum, I'm just not adding anything. I'm just ignoring this element, right? I'm just ignoring this element. So obviously it's the same thing. And when I'm returning, I have to add both of the cases, right? I have two options, right? I have two options, taking element or not taking element. But when I'm like giving the answer, I have to add both the cases, because in taking case I will get some of the solutions, in not taking case also I'll be getting some of the solutions. So I have to return take plus not take. Okay, let's come to the DP part, right? Like if you are submitting the recursion part, it's actually will be giving a TLE, right? TLE, time element extended. That's why we come to DP approach. That's also I have added the memorization. Like what is my DP array denotes? My DP array will be like DP of, let's see the limit here. Okay, see, this is the sum of all the elements. This limit is 1000, and the norms dot length limit is 20, right? So my DP array is like DP of n plus 1 of sum plus 1. right? dp of n plus 1 sum plus 1. So I have just taken the dp of 25 or this, okay, just that thing, okay. And this step is called memorization. Memorization. What is memorization? Just see, if I have already wait, before explaining memorization I have to explain this mem set. What is this mem set? This is a function, this is just a function which takes the whole dp array, and in the whole dp array it just set every value as -1, right? Every value as -1. It's just a function, right? Okay. So just see, if dp of label comma label sum is not equal to -1, that means I have already set some values for this dp, right? I have already set some values. I mean, like the value of this label and with sum is already calculated. Then I'll return this, right? This is a pretty standard step. This is called memorization. So this is the thing. And at last, when I'm finding the solution of this, I'm just saving it, right? This is the saving step. This is saving the answer, right? Okay. So this is the total solution, and the code of it I think I have already explained in a good way. Like, anyways, you can just draw the recursion diagram here, but I'm not going to prefer it, because like if you will follow this template, then we are gonna get every question of backtracking easily, right? So this is the thing. Thank you.